Sometimes it's gonna hurt. Sometimes it's gonna be painful. Sometimes
Assalamualaikum and blessed afternoon, everybody. Welcome to the fifth series webinar on STEM Career Prospect 2021, sharing on the career in dronology, a program brought to you by Rakan Strategic Persatuan Guru STEM Malaysia PGSM and Berkeso Malaysia. Here we are bringing you live in YouTube and Facebook Persatuan Guru STEM Malaysia PGSM. Good morning, dear audience. I'm JB Aliuddin and your webinar moderator. Ladies and gentlemen, STEM or science, technology, engineering, and mathematics is a hot global topic in education nowadays. STEM has been placed in the Malaysia Education Blueprint 2013 to 2025 under the Ministry of Education. It emphasizes on collaboration, communication, research, problem solving, critical thinking, and creativity skills. Today's topic is closely related to STEM, which we'll be hearing on STEM Career Prospect 2021, sharing on the career in dronology. Dear audience, allow me to share our speaker's background. He is the co-founder of Dronology, Sendirian Berhad, lead research engineer, a lead developer in UAV technologies. He has led development of drones since 2013. His notable work is with Project Natalie, where he built world's first autonomous agriculture spraying drone. He since has worked on bringing the technology to commercialization. Some of his notable works are Project Natalie 2013, collected and analyzed data for precise drone spray application method. Project Scarlet, whereby we led dronology commercial agriculture spraying drone development and support, create SOP for agricultural spray workflow. Project Mary, heavy lift quadcopter 2016, which is a leading development in confined space UAV developed non-GPS enabled area navigation system. and Project Saline 2019, lead Ronald G. Commercial Agriculture Spraying Drone Development and Support, create SOP for agricultural spray workflow. This co-founder of Dronology, Sundar Berhad, has also won awards over the years. In 2016, he won TEDx Speaker Drones Workforce for Food Production, and he was also awarded as one of DG Unsung Heroes in 2019. Remarkable achievement, I can say. Ladies and gentlemen, I'm sure all of us are excited from this new prospect in career development. And what is dronology? So let us all welcome Mr. David Amothezen, and Chief Research Officer and the co-founder of Dronology, Sundar Berhad. Please welcome, sir.
Hi. Thank you for having me.
Good morning, sir. How are you today?
I'm good. How are you?
Right. Very good. Thank you so much. Thank you for being with us.
You're welcome.
All right, to you, sir. Please enlighten us. What is Dronology is all about?
All right. Dronology is the company that I co-founded with another 3 partners of mine. We started back in 2015, early 2016. So we had a challenge to be addressed at that point where, especially on the paddy industry, where lack of manpower to work in the field has pushed, there's a bubble there, a cavity to be fulfilled. So we were given the challenge of coming up with a drone that is capable of spraying fertilizers, pesticides, and things like that. So back then, when we talk about 2015, there's not much of agricultural spraying drone. So we had to start from scratch. We had to design everything from scratch. So it was a long journey. So we somehow managed to get a fully autonomous drone to spray in the paddy field in 2016. Now we have a fleet of that working in the field. Apart from that, in dronology, we are more into research and development of products. So that has brought us to other avenues as well, other types of drones as well.
Okay, thank you, sir. Yesterday we did talk, and you did explain to us what is drone or dronology is all about, right? And it's not just about, yes.
Yeah,
it's not just about, yes. Can you please explain it to us, sir?
So common misconception is that the word drone, it means that, common misconception is that it's a flying vehicle, it has these motors, this propeller spinning and just flies, that's not a drone actually. I mean, it has more to it. In our understanding in dronology, drones means that anything that can move from point A to point B autonomously and come back to point A, that is considered drone. So for a good example, I would say there's a drone tractor, drone boat, drone ROV. So all that is considered drone. It's not just something that flies, but also something that moves on surface.
All right, sir. I'm talking about the career in dronology. Can you please explain or share with us? Maybe you have a few slides there that you can share with the audience today.
Oh yeah. Can we have the slide up? So okay, a bit about dronology. We are incorporated officially in 2016, but the work for the company started much earlier than that. We are 100% Malaysian owned, registered with Kementerian Kewangan, and our main industry that we serve is R&D into unmanned system for security, agriculture, and surveillance. We design, build, and test unmanned aerial systems for various industries. We have in-house development for electronics, circuit board, and ground control software. We also consult many unmanned system projects outside Malaysia as well. So this is my team basically. These are the Avengers in dronology. So Encik Faiz is the CEO of the dronology, and myself in research department, and Encik Abu Bakar is in systems development department, and Marfizol on the operations and support. So, all right, it's a bit too small to be seen on the screen, but it's basically our journey. We are incorporated in 2016, but our work on autonomous spraying drones started much earlier than that. So we were given a task whether can we build an autonomous drone for spraying. So we took that as a challenge. We came up with few prototypes, and we did a proof of concept back in 2016, where we had a drone that is capable of spraying liquid over paddy fields. But then that was not enough actually. Traditionally, farmers use much higher spray volume. Roughly per hectare, they'll use somewhere around 280 liters or 300 liters sprayed over an hectare. We can't do that with drones because drones have much less capacity. So we had to come up with a smart way. We had to come up with a solution. We can't be carrying 300 liters to spray over an hectare. That will not be economical. That will not be practical to be used with drones. So that's where we partnered with Agricultural Chemical Malaysia to formulate right suitable type of chemical that can be used. They had amazing engineers, chemical engineers who worked on this. So the goal was to reduce from 300 to something that is more manageable, like 30 to 20 liters or something. So the study went on for 6 months plus. I think I have a video footage later on in the slide. So we had multiple types of parameter to be tested. We need to find out the right types of nozzle that we can use, the right type of velocity on the drone, the right type of altitude of the drone over the paddy field. So in total, we had 48,000 different variables, and we had to go through all of it. So it was a good journey in collecting data and figuring out which one would be suitable to be used. After that, we started commercially spraying over paddy field, especially in Kedah, Perak, and Pulau Pinang. So it was an interesting journey because back then even farmers were reluctant to use this new technology. They were like, will this work? Will this harm my plant? And so much of things were going on their mind about drone working in this. So that's where we had to go on ground, educating the farmers. This is much safer than, traditional way of doing it. And in fact, the research that we did was we also collaborated with Jabatan Pertanian. So in one of the tests, Jabatan Pertanian actually gave us 4 hectares of land were split into 2 and 2. The first 2 is planted. Everything is done traditional way. The fertilizing, the pesticide spraying, everything was done traditional way. And the other 2 was with our new technology, with drone spraying and with much reduced spray volume per hectare. So it was like sitting down for an exam, hoping that we score more than what the traditional method would do. So we actually gained, if I'm not mistaken, 17 or 16% more. I think I have some in the next few slides. So we had 16% more, 17.25% more yield than traditional methods. So I would like to thank my partners and Agricultural Chemical Malaysia for the hard work that they have put in to get all those valuable data for us to have this success. So Dronology Scarlet is one of the product of extensive research by ACM and Dronology. Though we reduced spray volume, we did not cause any phytotoxicity to the plant. Okay, the term phytotoxicity is where the fertilizer or the pesticide turns into poison for the paddy plant itself. So if you have that, then it's a bad thing. You're just gonna kill your plants. We have also worked on various other industries for unmanned system. One of it is search and rescue. So this is again a proof of concept that we did, I think, a couple of years ago. Fully autonomous modular payload system search and rescue drone. So whereas in the market, if you want to have eyes on the sky, then you need one type of drone. If you have something for payload delivery, you need another type of a drone. If you have rescue assist, that's another type of a drone. So in total, you have to carry like 3 different drones to be used as for search and rescue. Whereas ours were modular, where if you want a camera, you can plug in a camera. If you want a payload drop, you can plug in the payload drop module. So we work together with Angkatan Pertahanan Malaysia to bring this into the field. Okay. So this is the pioneer team that sat down and worked with us in developing this search and rescue drone proof of concept version of this. So it was a fun journey working with them. Now we have a version 2 being prepared. So usually for version 1, our approach is we need something that can work for the task given, where we will compromise on the aesthetics of it. So whatever finding that we had on the first iteration of the product, we will address that on the second iteration, and as well as give good aesthetics to it. So the next one, maybe. We also design and build light show drones. So we have a fleet of light show drones that's being prepared right now. Hopefully, as soon as COVID goes away, then everyone can go outside and we can have light show. This is being fully designed by Dronology team in-house, and we are keen on bringing this to the market. Next. Like I mentioned earlier, we build everything in-house. We try to reduce as much as possible dependencies on outside, but then I think that's the nice part in research, where we can build things, and if it's not okay, then we can go back to the drawing board and we can start designing a new one. So we build circuit board in-house. So those who are experienced with soldering and things like that, we do cross wire at times, and the magic fume comes out. So actually comes so often once upon a time. So it's a fun thing to work in the lab. We take drone data security seriously. So everything that we assemble, design has to pass through a strict quality control, especially if it's going to be exported outside Malaysia. So we need to also fulfill other requirements like FCC and CE. And again, support. We stand by with our quality. If anything is wrong, we will exchange one-to-one. So let's say if the drone crashed because of because of flight computer error or circuit error or something that is not user's error, then we would actually exchange one to one. Again, this is the four Avengers that I was talking about earlier. So this drone that in the center here is actually our very first prototype for our drone spraying. So it was octocopter, and it has 8 motors, 8 propellers, and yeah, it was in 2015 or 2016, somewhere in there. So we prepared this in about 3 months from the date we were given, and yeah, we presented, and it was fully working. Back then, when I designed a spraying drone, I quickly realized one thing: if human flies this machine, for sure they're gonna crash, because fatigue, hot, it's tropical climate outside. It's easy to lose concentration. So that's where we had the idea of getting it fully autonomously spraying. You just plot where's your field, fill up the liquids, and it'll take off and fly, and it'll come back once the battery runs out or the chemical runs out. Next one. Okay, what I have prepared here is basically pictorial of the journey that I've gone through um, in dronology, developing drones. So this is definitely way back then. I'm so thin back then. Um, so this was our second prototype. We called her Marie. So the first iteration was Natalie. This was Marie. So Marie had a quadcopter configuration where it has 4 motors and 4 propellers with a tank capacity of 10 liter, if I'm not mistaken. And it has 4 nozzles. And so basically, Natalie was our research vehicle that we used for our spray efficacy study with ACM. On the right picture here is Faiz, one of my partner. So all of us on the field, hot day, we all worked to collect as much data as possible. Can we have the next slide? This is during the research with ACM. Maybe we can play and then I can explain more. All right. Since there's no music, let me go explain what's happening. So back in I think this was 2017, something like that. So uh, we had a drone, but we also had another big challenge to be addressed. Traditionally, farmers were spraying 300 liter. I mean, with water diluted fertilizer to 300 liter over an hectare. So the drone's tank capacity was just 10 liter. So it was not possible to put 300 liter to spray over an hectare. That will take like 30 flights to complete. 30 flight equals almost a day operation over an hectare. So there's no economic return in that. So we partnered with ACM to formulate chemicals suitable for this spray, paddy spray, without causing any phytotoxicity to the plant. So again, can we play once again the same video? Just a bit. So working with ACM, we had like close to 48,000 parameters to be tested, and in order to fine tune which one is the right, so we had to place water sensitive paper on the ground, marked every meter, and we fly different speed, different height, different nozzles, and collect as much data as possible. Come back and find out which one is the most suitable. So the whole process was almost 6 to 8 months. So every day morning we wake up, go onto the field, um, fly this machine and collect as much data as possible. We on this video we are actually spraying water. Most of the time we just spray water to collect data. Um, the reason why I'm saying we had to collect as much data as possible is that we don't want to give something that is very much not too less, not too much to the plant. So we just need to find the right balance in that. So these are the engineers, chemical engineers, agriculture engineers from ACM that worked with us, collecting data, collecting samples. So it was a fun journey working, collecting data and working with smart scientists in Malaysia. So yeah, that was a good experience throughout the journey that I had. Um, that J Baka here filling up water. Um, so it was a good experience. Oh, again, Mary. So once we done the research, we were flying one in the field. Crash happens. This one fell into the river. So this is some of the things that is interesting during research. Lah. It doesn't happen during commercial stage. It's more to the research. We were finding out which is which. So this was one of the funny experience that I had on the field. Can we have the next one? All right. Now we went into the field to test out our next generation after Marie fall into the river is called Emma. Emma had quadcopter configuration as well, but this time with 6 nozzles. So this is the team that worked in real paddy field, collecting real data during Emma's lifetime. Next one. Again, Emma has quadcopter configuration with 6 nozzles. So this is Emma being tested in a real paddy field, collecting real data over the span of 2 seasons, if I'm not mistaken. Next one. This is a short video of the whole findings and how the drone works. Can we have? We don't have audio though.
as introducing the crop spraying drone for rice paddy. It's fast, safe, and easy to use. Can you use a drone to spray the chemicals you are using now? The answer is not really. Doing so may not be effective, and worse, could damage or kill your crop. Here at Dronology, we conduct research with Agricultural Chemical Malaysia, ACM, to determine the correct chemical, concentration, and parameters for effective spraying. Research was done at Salama Research Center to design chemicals suitable for use with drones. Drones use a more concentrated mixture compared with traditional spraying. A wrong dosage may cause phytotoxicity, where the mixture becomes poison to the plant. Dronology performed research on the most effective parameters to spray the chemical: altitude, velocity, swath, nozzle type, spray volume, etc., and designed drones to specifically address the requirement. Together, ACM and Dronology conducted plot testing with Javatin Pertanian for a whole season. Result: an increase of 17.25% more yield. Join the agricultural revolution into the IT age. Start using drones for your next spread. With Dronology and ACM, you can rest assured that your crops are in good hands. Call us now.
So that's a brief explanation about the research and the outcome and marketing video from us. Can we have the next slide? Okay, after Emma, after Natalie, Marie, Emma, we had the next generation called Scarlett. So this is Scarlett spraying over paddy field in Kelantan. So Scarlett has a 6 propeller configuration with 8 nozzles. So we went from 4, 6, and 8 nozzles. So we improve on each iteration of the drone. And the best part about Scarlett, we started. When we go onto the field, then we had multiple challenges that we had to address. One of it was the heat, the tropical heat, especially in Malaysia. We have during middle of the noon, the temperature of the ambient temperature can reach up to 38 Celsius. We have recorded something 40 as well certain days. So heat was one of the issues, and computers, especially flight computers, doesn't really like heat, as well as batteries. Batteries doesn't like to operate in very hot and humid conditions as well. So what we did was we explored operation at night. So Scarlett was the first generation that we explored using getting the operation run at night. So if we can have the next slide. Okay, before I go to the night operation pictures, this is one of my partners, Chewbacca, is actually servicing the drone. So I thought this picture is a very nice composition. So thought of putting and sharing with you guys today. So this is in Kelantan. If I'm not mistaken, this is Kolam in Kelantan. So we were spraying in Kelantan for almost a year plus in this area. So this is one of the nice pictures that I thought of sharing. If you can have a next slide. Again, another picture taken. So this is right before harvest season comes out. So if you can see, our plot is clean and green and gold in color. So it shows how much efficient and how much it can improve in efficacy of this plant growth when product that is properly researched for this environment is put out on the field. This is picture during night operation. So at first it was daunting that we're going to operate at night. Of course, people had concerns that, what about the insects? Some even had concerns about what if we see ghosts on the field. based on our experience, we didn't see any of those. So it was a fun, and it was actually much more calm to work at night. So after we started doing operation at night, we completely converted our operation to night, because it's much more efficient, and yeah, you can get things done quickly without putting strain of yourself. When you put strain on yourself, you tend to do silly mistakes. So this improved a lot. Next. So earlier, whenever we spray water, we don't wear overalls and gloves and things like that. But when we do chemical sprays, um, this is the full PPE that we put in. We also wear an hat, but in this picture, I think I was just posing for the picture, so there's no hat. Um, so the picture on the right is I'm doing some programming work on the drone. On the far, you can see that's actually Natalie. Natalie is still with us today. Natalie has retired from spraying, but we still use Natalie for research and development on other projects. Next slide. On this video, we have two drones operating simultaneously, taking off, because we also figured out that if we can swarm these drones more than one unit, then we can improve the efficiency of the operation of the field. So in a bit you can actually see, okay,
Rolling.
yep. So both goes to different end on the field and start spraying. So it reduces the dependencies of your support personnel on ground, as well as improving efficiency in operation. Can we have a next slide?
Rolling.
Next slide. Okay, excuse me. So this is one of the circuit board that I designed to be on the drone. So how to put this? So whatever findings that we had on the agriculture drone, Natalie, Scarlett, Emma, and all that, we built a platform called Unified Design Platform, where if let's say we want to build a search and rescue drone, you don't have to come up with a whole new circuit or whole new architecture for it. You can actually adapt that to another product. So that is one of the findings that we had. If you're going to start anything from scratch, that's going to cost you a lot. So and we don't like spending a lot. So one of the good thing that we found is that we can, whatever findings that we had on the previous product can be used on the newer product. So this circuit board actually went into the light show drone. So this is one of the research that we did in dronology. Next slide. Okay, this is with the civil defense team, with the first generation of dronology Leia. Leia is the, as I mentioned earlier, it's a search and rescue drone. So it assists the search and rescue team on the field with three main tasks: eyes on the sky, payload drop, as well as rescue assist equipment. So it can carry gas monitoring sensors, multiple type of thermal cameras, visual cameras, and also deliver payloads to emergency situation scenarios. So It was a fun experience working on a different platform after agriculture platform. So now in Dronology, we don't only do agriculture, we also have multiple other industries that we have embarked on. Next one. Ah, yeah. So there's actually much more products, but I can't reveal until we have completed the study. So that's a pretty much that I can say about what we have done so far. There are many more things that I would like to share in future, but until we have, I have clearance to talk about it, then I can talk about it. So anyway, thank you for this opportunity for me to share all this. It's a great pleasure.
From Mr. David Amudesan, the co-founder of Dronology, Sir John Berhad, and a lead researcher here via YouTube and Facebook, Persatuan Drone STEM Malaysia, PGSM. All right, so thank you very much for the sharing. Actually, I'm intrigued to see all the slides being shown. I have a question here, sir, if you don't mind.
Sorry, if you could say it again.
Yes, sir. I've got a question here.
Yes, please.
Is it clear? Yes. I realized that all the drones were named after female names, and I do know that I do know
Yeah.
that we do have a belief for example, like ships. They even name ships based on female names. So yes, what is it to it, sir?
Okay. It's just for fun actually. So
I see.
yeah. So all of our drones, all of our platform has female names. So um, Natalie, Emma, Marie, Scarlett, Maya. So the whole fleet of them has female name.
All right. Okay, so we do have a question here from the audience.
Yes.
I'll read it in Bahasa Melayu. It asks, boleh ke setkan drone supaya menjadi auto drone? Ada sensor-sensor tersendiri dan boleh balik base bila bateri dah low, macam intelligent drone.
Okay, soalan yang bagus actually. I'll answer this in Malay also lah. Boleh,
Oh.
boleh. Uh, Memang dari hari pertama kami design drone di Dronology. Rule number one, the drone mestilah fully autonomous capable. Because kalau dia tak autonomous capable and you give the control untuk manusia bawa, for sure risk of crash tu lagi tinggi. So semua drone yang kami ada, including agriculture, search and rescue, all of it ada fully autonomous, and dia ada sensor for safety as well. So dia ada obstacle avoidance sensor, dia ada altimeter sensor. So there's enough sensor to fully automate this. Kalau bateri low dia akan balik sendiri. Kalau chemical habis pun dia akan balik sendiri. In case pilot nak bawa manual flight boleh, tapi we don't recommend it lah. We prefer fully autonomous operation. Kalau ada anomalies on the sensor, baru take over manual control and land.
Okay, there you go. Thank you, sir. Right, we would like to know, how did you get involved in Dronology?
Oh, that's a good question. I have to go back in 2015. Okay, so I was a student back then, and me and a bunch of my friends wanted to make short films. University students at that time, So one of these friend of mine wanted to do this aerial shot, but it was just too expensive to rent a helicopter to do that. So what we did, I said, maybe I can build something that can fly, So started building it and and then I realized that I'm not a good flyer. I'm not a good pilot. I kept crashing. So I made it autonomous, like can go from coordinate A to coordinate B, and coordinate B back to coordinate A. That's the only thing I could have I did lah. And then I started to get more involved in the drone. I stopped skipping class. I mean, I stopped attending the class. I started to skip quite a bit of class. And then word spread out that I'm building this machine, and one of my lecturer, which is now my partner in dronology, said, "Hey, I think I have people that might be interested in talking to you about drones." And that's where I met the other team, the other partners in dronology, and we sat down. We started exploring in what we can do for the paddy industry and things like that. The rest was history, lah. And I in between, I stopped attending class entirely. So in a way, I'm a dropout, but yeah.
But look at you now, such a successful person in dronology.
I don't know if I'm successful. It's just that I enjoy flying these things and building these things.
All right, Mr. David, I've read through some of the types of careers in dronology. We do have like pilot UAV drone jobs, drone engineer, as well as drone operator. And there is a drone pilot course by DJI Academy in Selangor. So I'm sure our youngsters, even students, are really into dronology because youngsters nowadays are into technology, right? What are the criteria or qualification needed for students to be part of this industry?
Okay, very good question. What I would say is that this industry, the drone industry, is at infant stage. What I mean by infant is we start to see technologies are evolving like rapidly in the drone industry itself. So what I can expect is that it's gonna be, in terms of qualification, it's gonna be from high school leavers all the way until PhD degree holders. So there are many opportunities for anyone in between that. I've seen people having PhD degrees studying on research and developing drones. I've seen SPM leavers taking up drone operation courses and getting on the field, flying this drone in the field as a last mile. So this industry in total is basically welcoming everyone. Doesn't really matter your qualification is, but it depends on the scope that you're gonna get into. I can foresee that a lot of young operators gonna be on the field embarking in the agriculture sector. So that's one of it that I'm very keen on seeing. I think 5 years ago, I'm pretty sure not many youngsters would be interested in going into agriculture sector. It's such a taboo to see young guys working in agriculture sector back then. But nowadays, I'm seeing quite a number of SPM leavers, university grads who have tough time finding job, actually getting these drones and operating on the field. So it's a very welcoming industry, and it welcomes everyone. That's what I can foresee for now.
All right, sir. I actually agree with you when you said something about agriculture, because agriculture is one of the KPI of our director, Sabah State Education Director, one of the KPI in TVET, whereby we encourage schools to offer more of agriculture subject nowadays, especially when we talk about STEM. So, Mr. David, please share with us, because we do know dronology is a huge facet of career prospect, and the industry has actually developed and still developing. So do share with us, what is the long-term prospect in dronology in this industry itself?
Okay, what are the prospects? As I mentioned earlier, this is a very infant industry. Actually, history can teach us a lot. So if you look at the dot-com bubble back in the late 90s, many people have no idea what internet is all about, what is personal computers all about. But the world, fast forward 20 years later, everything nowadays pretty much dependent on these dot coms, personal computers. Another good example is that in I'll take paddy industry as a good example. In the late 90s as well, when harvesting machine was introduced to cut these paddy to harvest the yield, many of the farmers were reluctant, saying that this machine gonna cause spillage, gonna cause damage to the land, and things like that. Fast forward 20 years later, no one doing hand cut paddies anymore. Everything is done by mechanization. So same with drones. Fast forward, I'm not predicting the future, but I can foresee that in about maybe in a 10 years time from now, we're going to see packages being delivered by drone. So when drones are delivering packages to your house, you're going to need a set of people for MRO, maintenance, repair, overhaul of the drone. You're going to need a whole team of operations, whole team of pilots conducting all these operations. So it's pretty much, we are at the beginning or at the juncture of something big. So the prospect is very much open and looking good.
I think so. You put a big smile to our youngsters to hear
Of
what's the
course,
prospect of dronology. Yes.
the drone industry by itself is very infant, and the growth rate is exponential in the past 4 or 5 years. I've seen a lot of companies are investing into this, a lot of money coming in, money going out in research and developments. So I'm overwhelmed to tell how much of developments are happening, how much things are evolving. So to answer your question, it's a very good prospect ahead.
Right. We do know dronology is being used a lot in agriculture, even defense and search and rescue. What are the sectors that could actually use dronology or actually being still using dronology nowadays?
Okay, dronology as a company, we started from agriculture, and then we ventured into search and rescue. We also had survey projects for geological survey. So in recent times, we had opportunity to work on other sectors as well, especially in geophysical studies and things like that. So something new for us. Yeah, again, those are the projects that I'm currently working on, and until I have a final product, I can't really talk about it. So
Okay, understood, sir. All right, so more questions are coming in.
yeah,
Um,
good.
Yes. Okay, apakah teknologi terkini tentang drone sekarang?
Very subjective question, sebab drone is evolving too fast. If I say terkini, by the time I finish the word terkini, there's something new about drones out already. So teknologi terkini tentang drone sekarang, I think now it's more into how to say, drones are finding their industry scope. That's the right way I can put it. For example, before this, agriculture industry pun never thought of having drone. So they knew that okay, drone is very helpful nowadays. So farmers, everyone like tengah cari drone nak spray untuk land dorang kan. So sama juga macam industri geophysics. Traditionally, geophysics will have man walking around the field to get it done. So right now, I would say drone is finding its home in each industry.
Right, thank you, sir. Going to the next question. Ada jual small drone for education ke atau ada DIY drone?
Okay, we don't sell DIY drones or anything retails. In dronology, we don't do any retail sales, but we do have education drones. We actually put that product for STEM Study Lab. It has a basic set of drones with some tools so that students can learn on how to get this drone, basic stuff about how to fly, how to maintain, because all drones are different. For example, if you take agriculture drone to search and rescue drone, it's completely different. The one that we have is basically for learning purposes lah. It just gets you to the basic level, and then from there you find your way out. You know which industry you like to venture on.
I see, sir. Would you like to share with us what are the challenges in actually creating and conducting drones throughout your career?
Oh, the whole journey was a challenge. Okay, when I first ventured, people thought I was crazy to embark on toys. I'm taking toys to do something that is industrial. So I've seen addressing that was a big challenge. And then the next challenge was, of course, when we do research and development, it was financially, it was training. So convincing investors to come in to get this done was one of the challenge. Um, Other challenges was, one of the major challenge was, we did all the research, we had the chemical ready, we have the drone ready. The next challenge was addressing the farmers. They were very reluctant on new technologies. One of the reasons that I often hear was, I dah buat benda ni 3 generation, and you coming me telling me that this would work. So that was a challenge lah, because we had a research backed product, but the mindset wasn't ready on the ground side. So that was the challenges. Another challenge is finding suitable manpower to work on the field. It includes day-to-day operation as well as research operations. So because the industry was so infant, there's not many people who are expert on this. So we had tough time finding right person, and then we realized that okay, it's gonna be tough. We might as well hire someone and train them all the way out, and that's how we did it lah, in the end.
All right, sir. We do know that STEM itself emphasizes on collaboration, communication, research, problem solving, critical thinking, and creativity skills, to name a few. So, do you think those skills are actually applicable in dronology?
Of course, of course. All those skills are very much applicable in dronology. Whatever we learn, it's always useful, especially something that is very involving, like day-to-day operations and things like that.
All right. Last question from us, sir. What
Yeah.
is or what are your advice to
Mhm.
our youngsters, especially students who are very much interested in dronology and would like to be part of dronology one day? So, what is your advice to them? How should they prepare themselves from now? And yes, what can you actually advise them?
The only advice that I think is very much suitable for them would be curious. Be curious on how things work, how you can improve upon it. Um, doesn't matter if you're in research and development field or you are in operation field, you always find a way to improve things. So if you're curious, you'll find a way to improve things. If you're curious about getting into dronology, then you'll be curious on what are the things you need to train yourself, and you'll find that you might need training, STEM training, or so being curious is one of the way to gain knowledge. So stay curious and yeah, gain as much knowledge as possible. Knowledge doesn't mean you have to study by the books. It could be what you are interested in. You might not be interested in certain subjects, but you have total interest on one subject, then you just go for it. So stay curious. I think that's the best, I would say, being someone in my shoe, research and development. So yeah, stay curious.
Thank you very much, sir. Maybe one day when everything is settled and everything is getting better with the pandemic, so maybe we can bring our students to visit Dronology Sdn Bhd in KL and
Yeah,
see
sure.
Mr. David. And maybe
Very
Mr.
much
David can
welcome.
show us, right? Yeah, maybe he
Yeah,
can show us
yeah.
how do the drones work and everything, right? Yeah.
Oh yeah, yeah. I mean, it'll be pleasure for me to show that. Yeah.
I'm sure the students would love to do all the hands-on activities, right?
Yeah, yeah, yeah. It'll be a fun place to work and fun place to hang around. So very much welcomed.
Okay, thank you very much, Mr. David. To students out there, you might be part of Mr. David's team in Dronology Sdn Bhd one day, we hope, and be able to invent your own product in the future. Thank you very much, Mr. David, for the insights. Ladies and gentlemen, Mr. David Amodesan from
Yes, thank you. Thank you.
everybody is actually eligible to be part of this career as long as you've got the passion and always be curious. Ladies and gentlemen, members of the audience, hopefully the insights are able to motivate our dear educators in Malaysia. And importantly, it would motivate our younger generation to choose the path in dronology as a career. Science, technology, engineering, and mathematics, STEM is important because it encompasses every part of our life. The concept of science and mathematics are all around us. Technology and engineering, these are crucial and necessary in our daily life. Dronology is part of STEM itself, and it sure does offer a variety of secure jobs in the market for someone who is interested in having dronology as a career. So for those who have the passion and wanting to be part of dronology industry, you know what is needed to be done. Follow your dreams and passion, make it happen. One day you might be as successful as our speaker, Mr. David, and create your name in dronology career or industry. Importantly, you will contribute a lot in helping the younger generation and our country towards future development. We're very sure. So ladies and gentlemen, members of the audience, we would like to thank all of you for joining us here in Persatuan Guru STEM Malaysia PGSM YouTube channel and Facebook today. Do not forget to fill in the attendance link for the SPLKFM record as well as the digital certificate for today's program, and also be free to join Persatuan Guru STEM Malaysia PGSM. Do like, subscribe, and share our YouTube and Facebook channels. Your support and deeds mean so much to us. Never give up, reach for the stars, but safety and health always come first. Thank you, and our biggest gratitude to our speaker today for kindly sharing with us. A big applause for Mr. David Amodesan, co-founder of Dronology Sdn Bhd. On behalf of Persatuan Guru STEM Malaysia, PGSM, and Perkeso, we would like to convey our utmost gratitude to all, and do join again next time. Thank you from me, Debbie Anyudin, and our technical manager, Mr. Amli Ahmad. Assalamualaikum, and have a great weekend, everybody. Thank you, Mr. David. Thank you very much,
Thank
sir.
you. Thank you.